platforms are disrupting and democratizing software development. By decreasing or removing entirely the programming knowledge needed to build applications, these platforms are changing the landscape of development. Speedier time to delivery on a no or low-code platform changes the expectation that development is an inherently time and labor-intensive ordeal, and many platforms are expanding the definition of who can contribute to application developer. Enter the citizen developer. PDF will of course be a very important part of many applications built using these platforms, and in this session attendees will take away an understanding of current low-code, no-code platforms and what is required behind the scenes to add PDF functionality to those platforms. Analysts Gartner predict that by 2025, an astonishing 70% of new enterprise applications will use low-code or no-code technologies. So clearly this is a hugely important trend and will have a significant impact on development of PDF document processing applications moving into the future. This session aims to answer these key questions really. What is low-code development, and what are the implications for PDF developers and PDF technology companies? In more detail, our agenda will be split between background, technical implementation, and a look into the future. The background will explain what has brought about the rise of low-code and look at some practical examples of low-code platforms and PDF processing in those platforms. As we will see, the majority of low-code platforms have little in the way of built-in PDF capabilities, so we will look in some detail at what is required to extend low-code platforms to include PDF functionality. So where are we today? The big driver behind the rise in low-code platforms comes from surging demand for applications following digital transformation generally, but it's been exacerbated by the increase in remote working following COVID. The figures on this slide are from Microsoft, and other figures may vary. But the key point is we are in need of huge numbers of additional developers in order to be able to support the demand that we currently have today for digital applications. So the question we have, of course, is how are we going to tackle this challenge? Well, there seem perhaps to be a couple of choices. One option, of course, is trying to teach everyone to code, but rather than trying to teach everyone to be able to code using traditional technologies, which is perhaps not a realistic proposition, much of the demand for application solutions can be met by turning everyone into a developer with low-code technologies and platforms, and this is the revolution that we are seeing right now. Interestingly, we may have been here before. We can actually go back 40 years and we see some similar themes. The issue of relying on programmers for application development with related days and problems has been around for a long time. If we take a look back 40 years ago when James Martin published his book Application Development Without Programmers, we've had a good idea of the direction in which software development is headed. In the years that followed, software companies introduced various computer-assisted software engineering tools, CASE tools, fourth generation languages, 4GLs, and rapid application development tools, RAD tools, with varying degrees of success. Rather amusingly, in 1981, a British company created a solution called The Last One, which was touted as the last computer program that would ever be written. It was claimed that it could generate other programs automatically from English language and eliminate the need for programmers. It turned out to be useful only in a very small number of use cases, so only had limited success. Perhaps early spreadsheets such as VisiCalc and Lotus 123 are the best examples of early low-code platforms. Before they were introduced, of course, many simple calculations would have needed to be programmed. All of the tools we've just mentioned aim to hasten the speed of software development, in part by lessening the amount of manual coding needed. And it's this thinking that would eventually lead to the creation of low-code platforms. Can you imagine a world without spreadsheets now? In the future, we won't be able to imagine a world without low-code platforms. But of course, in 1981, we didn't have the cloud, and it's this move towards cloud-based low-code platforms that's causing the disruption to traditional methods of software development, and it impacts both professional development teams and citizen developers. So it's important to note that the technologies can be used as much to accelerate the productivity of current developers in professional IT departments, as well as new business users. So what exactly is low-code, no-code? Well, low-code development is a way for developers to design applications quickly and with minimum hand coding, and in a minute we'll see some practical examples of this. Low-code platforms are typically cloud-based, although not always, but with the use of drag-and-drop features, Lego-like intuitive components and business process maps, everyone can create custom digital solutions for their needs. And it allows businesses to rapidly address their challenges by coming up with quick digital solutions that require no deep coding knowledge. We've been using the terms no-code and low-code, so I think it's worth spending a moment just trying to sort of establish, well, what really is the difference between these two terms. Sometimes the differences can be subtle, but broadly speaking, we can say that no-code platforms will be easier to learn and perhaps more suitable for citizen developers than perhaps sort of IT professionals, but they may have less control and flexibility. So in some of the platforms, we'll look at some examples of these, but we'll see that some platforms are geared very much to making it as easy as possible for anybody to develop a solution quickly, but it may not have more advanced capabilities that some developers may require and may not have all the control, flexibility and security that may be needed. But in both cases, solutions can be actually developed very quickly with these platforms, and particularly the no-code solutions are suitable for what we might term citizen developers. So citizen development is a business process that encourages non-IT trained employees to become software developers using IT-sanctioned low-code, no-code platforms to create business applications. This approach to software developers or software development enables employees, despite their lack of formal education in coding, to become citizen developers. They can create and customize existing software programs to suit a user's specific needs and improve operational efficiency within a company. Now, these low-code, no-code platforms include the necessary lines of code behind the scenes, so users just simply drag and drop icons to create and update applications. These platform simple visual tools allow different application functions to connect components across business units, apply action, test, and make sure the programming works as expected and publish the new code. So clearly this has a lot of advantages in terms of freeing up the professional IT teams for other solutions, increasing the speed. But there are also some cons and some management issues to worry about. Clearly there's a need to have at least some sort of governance of these platforms, ensure that the platforms are approved by IT to eliminate any possible security or other issues. But overall, they're generally regarded by most organizations as extremely positive. There is no specific standard for low-code, no-code, so to provide some useful practical examples of PDF and low-code, we do need to reference some specific products. There are a large number of low-code, no-code platforms available, and a few of which we've shown here. And it's worth noting that different platforms will have different areas of focus. For example, Bubble is aimed at building web applications, whereas Zapier is targeted at process flow and integration of different platforms. In terms of PDF document processing, common use cases include PDF generation, data extraction from PDF, and a wide range of PDF document conversion and manipulation operations. And it's very important to note that most low-code, no-code platforms typically have very limited PDF functionality built in. So the PDF community is needed to build extensions to these platforms to actually give users the functionality they need. Now, a number of these platforms are extensible, but actually not all of them. And as we can see here, by looking at these three platform examples, Power Automate, Zapier, and Salesforce, searching for the keyword PDF within each platform, we can see that several members of the PDF Association have created integrations to enhance the PDF capabilities of these platforms. And this is very important to both ensure that PDF capabilities demanded by users can be provided via these platforms, and of course the PDF continues its position as the preeminent document format. We're now going to look at three practical examples of PDF in low-code platforms. Of the many platforms available, we chose three that we thought would be of most interest to the PDF community. These three are some of the most popular platforms and are extensible to allow for more advanced PDF functionality. The three examples we'll look at are as follows. Firstly, we'll take a look at a process flow in Zapier that involves PDF compression. Then we'll see an example of PDF generation using Salesforce. And finally, we'll examine an example of process flow in Microsoft Power Automate that makes use of PDF data extraction. Our first example using the Zapier platform, which we'll show in a moment, we'll have the process flow shown, and this is the depiction within Zapier that you would see of this process flow. So the first step, when a new email is received into a particular inbox, and as we'll see when we look in more detail, only continue if there is an attachment, a PDF attachment, then the PDF file will be compressed, and then that file will be moved to a specific Dropbox location. So let's have a look at this in practice now. So now we're going to look at the effect of the process flow we've got. Here I've got an email I've got to send. You can notice the PDF attachment to that email was 5 megabytes, and what I'm showing now here is once that process is actually completed, as we saw there, it will actually be uploaded to this particular Dropbox and has been compressed to just under 2 megabytes. So that's what happens, but let's look at each of these steps in Zapier and how the data flows between each of them. The first step is a trigger step, and this is what's required to actually get the launch the process in the background anyway. And what we've asked it to do is find when a new email arrives in a particular inbox, that will be the trigger for this whole process. At various stages we can have filters, and in this particular filter what we're doing is we're just testing to see whether it has an attachment. Otherwise we won't actually attempt to process this email any further. And the next step here, this is where we're actually doing the reduction in the PDF. We're using a proof of concept that we've built with Passport PDF, and what that will actually do is use an API key, as is typical for many of these extension capabilities. And actually the action will actually make use of files from the previous stage of the process, the attached files in this particular case, and take that, and it will then of course produce an output which we'll be then using in our next step to upload into Dropbox. So you can see there, as you'd expect, we will have to specify which account we're using for Dropbox, which particular folder we want to go in, how we want the file named, and so on, and actually where the file actually comes from. So it comes from the particular previous step. So hopefully you can see that there's a sort of flow of document processing that occurs in this particular platform. And we're sort of joining these sort of flows together, almost like Lego in some ways, and we're actually able to define exactly what we want to happen at each stage. And the benefit of particularly the Zapier platform, it's very easy for people to manage this themselves without requiring any code at all. For our next example, using Salesforce, we'll show PDF generation using a custom document template that's driven by dynamic data. The Salesforce platform is of course primarily a CRM system, but it has a huge number of capabilities in there that enable business users to be able to extend and adapt the functionality of the platform. And this has a lot of value in terms of eliminating some of the need for IT departments to actually sort of build particular functionality for their end users. And it has a fair amount of basic PDF functionality, which we'll take a look at, but more advanced cases may actually need some of the extensions that are actually available. So we'll take a look now at this. What we're looking at here is how an end user would go about actually creating just a simple template document. I'm just finishing this off now by adding in the logo here with an alternate description for the visually impaired, and perhaps we'll drag in another sort of data field as well, just to demonstrate how this actually works. Maybe we'll take the last modified by date and just put it in here. So this is basically the sort of very simple template that a user is able to actually create to provide quotes. So if they go back to the record in their system where they're wanting to actually create a quote for an end user, you can see they can preview this PDF, which now reflects the changes that they've made, and they can actually then go ahead and actually email that. So whilst this is fairly basic functionality, it does have an awful lot of benefit from the IT departments, because the end users themselves are able to go and edit the templates. So that does actually simplify things and give business users the ability to make things look and behave the way they actually would like, without requiring any code or any assistance from IT. In our final example, we're going to take a look at Microsoft's Power Automate platform. And here we're going to look at this example here. So when a new invoice in PDF format is added to a particular SharePoint library, we're going to pass that document to a particular step which will actually extract data from that invoice, and then that data will then be used to update some of the metadata inside the SharePoint library. But it's probably best if we actually go and take a look at this in practice now. So what we're looking at here is three imaginary, very simple invoices which we'll use for the purposes of demonstration here. And what we're going to do with these three invoices, we're just going to take those and populate our SharePoint library with these. And they're being uploaded now. And as you can see, there is space for the metadata for invoice number and the total amount of the invoice. But and it is that we want to populate automatically using this method. So this is the process we go through. Now the trigger for initiating this process is when a new file is created and added to this particular library. When a new file is added there, then it will launch this particular series of actions, and it will pass the file content into this second step, which will be able to get the content of that PDF file using the identifier from the previous step. And most importantly, this then enables our PDF specific step to grab the contents of that PDF file, and we're just asking it to go and find the invoice number and grand total amounts from that particular file. There are quite a lot more options available from this particular step, but we don't need to really go into the details here. We're just trying to get the principles across. And once that process has been completed, it will actually be able to take values from that previous step, the invoice number and the grand total, and actually what we want to see it doing is apply those values into those metadata columns. So if we go back and look at the run history, which we'll have inside the Power Automate platform, looks to me like that has that's just finished now. So we can now see that it's actually added the relevant metadata. Again, that's to do that in code would actually require quite a lot of work, be sophisticated, whereas using the Power Automate platform, we're able to do something fairly sophisticated with no code in this case, by using a PDF extension. This particular one happens to be ours, which I'm just using by way of an example. So now that we've taken some examples of looking at PDF extensions in low-code platforms, the natural next question is, well, how do we actually go about building some of our own PDF technologies into one of these platforms? So what we're going to do to answer that is actually look at a real example of adding, actually the example we just looked at, the get data example from PDF, and just look at how would we go about adding that into Microsoft Power Automate, which was the example we looked at there. And what this is going to involve us giving an explanation of is the cloud service architecture that sits behind this platform and where we would fit into it, how the APIs and backends are defined, where does the interface come from, and touch on some of the other critical things about these kind of cloud platforms, scaling up, scaling out. And also one other area that's quite critical for both performance and data protection is that of geography and regions that are actually being used. So what we're showing here is the cloud service architecture that sits behind a platform such as Microsoft Power Automate and how we fit into it. We will be looking at each of these pieces in turn, but probably just to give an overview, it's perhaps best just to show how data and documents will actually flow through each of these sections. So the first step, as you've already seen, is this sort of series of process steps that are defined in Microsoft Power Automate in our particular example. And each of those particular steps is either using perhaps an inbuilt step from Microsoft, but or some another third party, such as the PDF extension that we actually looked at. But the data for processing will be managed step by step, and as we've seen clearly from our custom connector, this is the sort of Microsoft name for our particular step here, we need to have a way of being passed that PDF document that we then need to process, and we'll talk about how that's set up with an Open API definition and the related policies. But once that has been passed via our Open API definition, there's a whole API management process in this central area that does many different things, implements policies, checks subscription keys, and so forth. And really, this sort of acts as an interface to the sort of back-end services, and it's the back-end services where this is actually implemented. In our case, these are durable Azure functions, but they could be, implemented in many other different types of technologies, perhaps existing web services and so forth. But again, it's those responsibility of those services to actually return the results again via API management, and again back through the platform, so that then the results of that. In our particular example, is actually just some data. So we're taking a PDF as input and just returning some pieces of data as output. But as you can imagine, many other steps may do sort of return PDF documents, which would then need to be passed further on. So, but we are going to look in a little bit more detail at each of these pieces of the overall architecture. And central to the architecture is the Open API definition, which may also be referred to as a Swagger file. The Open API definition is the contract or blueprint to describe the different operations your application will provide, and the request type it's expecting, and the response type it will provide. And usually, in terms of design of these, in implementing these components, that is usually the starting point. And it's so critically important to really the overall structure of everything that's being put together. The Open API definition is used in all the components, so that each component understands the API's operations and its data structures. But actually, more than that, it's also used to define the fields and so forth that would be used for input, so that impacts on how the user interface will appear to the end user. And furthermore, it's actually used to, at least in the Microsoft case, to actually automatically generate documentation. So this is what you would see on the Microsoft site for this particular connector, and that would have been generated automatically from the Open API definition. The back-end services will perform the operations defined in the Open API definition. These services are usually microservices, but also can be web apps, containers, etc., or a combination of these together. And these are known as the back-end APIs. For our connector example, we use Azure Durable Functions to implement the operations, and that's one of the many ways to build microservices. In our case, it's particularly useful because it makes it very easy to scale up and scale out the service, as we will discuss shortly. Once implemented, we have an Azure Function endpoint, which the Azure API management will use to route requests from the client applications for processing. Then, at the central to all this processing, the Azure API management is used as a gateway to front the back-end service we implemented through the front-end APIs. It's used to avoid direct client access to particular service communication, so we're avoiding Power Automate being able to directly communicate to our back-end services, so we have this intermediate layer. And it's the first thing that gets hit when an application calls our API, and it routes the request to the back-end service, such as the Azure Function endpoint. And that's a separate URL from the front-end URL used by client applications and not exposed to the public. So why do we have this extra layer instead of calling the back-end endpoint directly? In addition to acting as a facade or reverse proxy to the back-end services, it helps secure, transform, maintain and monitor the back-end services by shortcutting some of the processing and offloading them here without the need to change any code in the back-end services. The custom connector is a wrapper around our Open API definition that enables Power Automate to communicate to our back-end API. When adding the custom connector to Power Automate, a user would supply the API key that they've received during their registration. Now, the custom connector can be configured to have policies that run at runtime, and one particularly useful usage of these policies is to route requests from Power Automate or other client applications to the correct region if your data must remain in a specific region because of data protection and privacy. And of course, as you would expect, the connector itself does need to be certified by Microsoft before it can be made fully available to regular users on this platform. Now, regions is the concept of regions is a critical issue for data protection. Typically, users will firstly choose which region they're running Power Automate in themselves, but then that is not necessarily the same region as where some of these back-end processing may take place. For example, in our case, we're based in the UK, so by default, our connector runs in the UK. And what this would then mean is that a customer in the United States would actually be sending their PDF data from the United States to the United Kingdom and having the data or updated PDF returned. Now, naturally, many users will want control over the regions they actually they run with, and in fact, in particular, in the United States, there are a number of government regions provided by Microsoft in Azure. So again, there's demand from those. So being able to control where your data goes, particularly for a worldwide audience, is actually quite important, and actually having this control is a critically important part of the overall platform and infrastructure. One other hugely important aspect of providing these kind of cloud services is to ensure that we've got enough resources to be able to service all the requests that are coming in. And there's two important concepts that help us do that. Those are the concepts of scaling up and scaling out. So scaling up, as you can see in this example here, is really having control over what sort of virtual machine you actually have running your back-end functions. So we can choose various different levels of machine to actually sort of support the functions we've got behind it. But, and equally or even more importantly, is the concept of scaling out. And this having the ability to support elastic scale out is critically important, because we don't want to have 100 virtual machines sitting there idle, but equally if we have a sudden burst of requests with a huge load coming in, we do want to make sure we've got enough capability behind that. So Microsoft Azure, similar to our other cloud platforms, will allow us to have this elastic scale out, where we can decide the sort of minimum and maximum number of instances we actually have available to our population of users, and in this way ensure that we can actually fully support all their needs. Just like all the other platforms, there is a support requirement, and there's a need to sort of monitor how the performance is going, the number of users and so forth, really just to make sure that the response times continue to be in the sort of required range, and that there are no problems. But all the cloud platforms will have similar capabilities to the ones we're seeing here inside Microsoft Azure. So, just to summarise what we've looked at in terms of the technical implementation, we really asked ourselves the question of, well, what is it going to take to build PDF technologies into low-code platforms? We want to make it as easy as possible for end users to be able to take advantage of advanced capabilities that we may have in SDKs or other sort of technologies. And what we've talked through here is what that actually involves in terms of the cloud service architecture, the APIs, the backends, and the other sort of service administration aspects of it. So hopefully that has helped explain what a sort of realistic implementation may actually look like if this is something you're thinking about doing yourselves. So what do we see of the future of low-code and PDF? Well, perhaps one of the most important questions is the extent to which PDF capabilities will be automatically built into these platforms, or will users have to rely on extensions available through marketplaces, such as the ones we've looked at? Based on what we're seeing at the minute, I think PDF extensions seem to be the most common route going forward, with platform owners building in maybe the very basic PDF capabilities they need, and looking to third parties, such as many of the members of the PDF Association, to sort of provide the extensions. More generally, the concept of hyper-automation is gathering pace, and this is really the idea that organizations will absolutely maximize the amount of automation they can do now that these platforms are becoming available, more easy to use for people to gain business advantage. And very much artificial intelligence is expected to be a sort of big part of that automation. as usage of these platforms becomes increasingly critical, enterprise trust, or in really ensuring that security is at the foremost of every aspect of the implementation, becomes important. And the idea of fusion teams is where there'll be sort of much closer practical cooperation between citizen developers and the IT teams, really again looking to sort of rapidly implement quite important business processes and applications in a joint fashion together, using some of these platforms that we've been looking at. So to summarise, we've taken a look at the background of low code, talked about what is low code, no code, provided a number of examples of using PDF in some of these low code platforms, and then we've taken a look at what is actually going to be required to add these sort of extensions for PDF capability into these platforms. And finally, we just touched on a bit of the potential future in these areas. Hope everyone found this an interesting and useful presentation. Thank you very much.
All right, great. Thank you very much, Neil. It's time for some questions. Let's first of all get your camera started. There you are. Thanks very much. That was an excellent presentation. Let's see. First question I have here. In your experience, what was the most complex part of putting together an integration for low-code platform?
Well, as you may have noticed from the cloud architecture, there's an awful lot of moving parts involved to make this work successfully. And although each one of them may in its own right be not so hard, there's the PDF code, there's the API definition, there's the API subscription keys, and all the cloud configurations. It's actually the orchestration of all these components, I think, that is the most difficult aspect of making this work successfully. But I think that's probably sort of common to many cloud implementations as well. But as we see out in the marketplace, quite a few members of the PDF Association have successfully created solutions here.
Okay, and then the next question is sort of similar in a sense, but how much time does it take to make yourself familiar with this sort of platform?
So the reality, yeah. So I mean, in our case, we have been working with this for probably a few years now. But I would, if you were starting from scratch, I would certainly allow several months to really become fully familiar and up to speed. The speed with each of the components.
Okay. With the growth of low code, will there still be a need for? I think I know the answer to this one, but I'm very curious to hear what you're going to say. With the growth of low code, will there still be a need for traditional PDF SDKs?
Yes, I'm sure there will. I don't think traditional SDKs are going anywhere. But what I do think, though, is there will be a lot of growth in these low-code platforms. And I would also expect probably that perhaps a lot of the organizations that provide PDF SDKs will sort of provide these facilities on these platforms as well. But as you may have noticed, probably the most important thing to perhaps notice is that the SDKs are clearly general purpose and can be used for almost anything, but most of these low-code platforms get their strength from having a relatively narrow sort of capability of functionalities that they're excellent at and really easy for people to use, but they don't try to do everything that you might be able to do in a regular SDK.
Right. Okay. So is all low code processing really going to happen in the cloud, or is there what's the role for low code on premise?
Right, so that's a very interesting question, because at the moment, if you look out there, most of the platform, pretty much nearly all the platforms are very much cloud focused, but we certainly see there's still an awful lot, and I think will continue to be an awful lot of demand for on-premise processing of this nature. And there are various reasons, like security. Sometimes the need to integrate with internal systems that can be really hard, would be tough to do via the cloud. And sometimes just the sheer volumes make it just the traffic problematic. So we certainly see there's a need there, and so I think some of the platform vendors are starting to see this. For example, Microsoft do have the concept of a sort of an on-premise gateway that allows you to sort of have a hybrid solution. But I do think also there's opportunities to actually provide these types of solutions that are sort of completely on-premise as well.